Recently, the James Webb Space Telescope observed two clouds on Titan, thereby aiding researchers in their exploration of Saturn's unique moon. Titan is a celestial body of fascinating contrasts, exhibiting both striking similarities to Earth and utterly unique characteristics. It is composed primarily of water ice, with rivers and seas filled with methane and other hydrocarbons. Accompanying that is a dense, hazy atmosphere punctuated by methane clouds. According to Connor Nixon, an astronomer at NASA's Goddard Space Flight Center in Maryland, the James Webb Space Telescope is scheduled to spend a total of 15 hours in its first year observing Titan. Specifically, Nixon and his colleagues wanted to study Titan's atmosphere to map the distribution of its haze and identify new types of gases. Scientists were utterly amazed by the data sent back by the James Webb Space Telescope. During data analysis, the research team identified the existence of two clouds, including the cloud located above Kraken Mare, the largest sea on the moon Titan. They quickly developed a method to analyze clouds in order to examine their changes over time. Nixon's team contacted the double observatories in Hawaii, which had just conducted observations of the Titan missile merely 2 nights after the Webb event. According to Imkara Pater, an astronomer at the University of California, Berkeley, "We were afraid the cloud would have disappeared when we observed Titan for the second time, 2 days later. But we were overjoyed to see that the cloud was still there, except its shape seemed to have changed." Scientists predict that the increased cloud activity in Titan's northern hemisphere is because this region is experiencing summer and receiving more solar radiation. They identify clouds in images captured using near-infrared cameras, similar to those found in night vision webcams. A powerful camera can capture images of a target at various wavelengths of light. In the case of Titan, this allowed the research team to isolate and analyze its lower atmosphere. Researchers have not yet completed the assessment of all the orange data. The near-infrared, NIR, spectrometer on the DEM website is also in the process of collecting data's atmosphere into its components and then measure the light. Scheduled for 2023, the James Webb Telescope is also set to observe the atmospheric layer surrounding Titan. This time, by using the MIRI infrared instrument, we have gained a clearer understanding of the chemical composition in Titan's atmosphere. NASA is currently developing a new mission called Dragonfly. The drone will fly through the thick layer of fog that shrouds Titan's sky. The moon has conditions similar to those on Earth 4 billion years ago, making it a potential place to search for the origins and signs of life. If successful, Dragonfly could help us explore the process of how life formed on Earth. It thus provides valuable data for the search for life in the universe. The Dragonfly project is part of NASA's New Frontiers program, aiming to understand how chemical conditions pave the way for the formation and development of biological organizations. For a long time, Titan has been considered by the scientific community to be a promising research target in the search for environments capable of supporting microbial life. Titan's surface is primarily composed of sand dunes and regions containing liquid hydrocarbons such as methane and ethane. The surface of this moon is composed of a layer of ice as hard as rock. Beneath the surface layer lies a reservoir of water in liquid form. This passage is said to have the same temperature as the shallow waters of the Pacific Ocean. Titan's organic chemical composition contains complex molecules that could provide the foundation for the formation and development of life. The Dragonfly project has a budget of up to $850 million, not including launch and operational costs. Scheduled for launch in 2026, the spacecraft will traverse a 1.6 billion kilometer journey and reach Titan as early as 2034. This spacecraft is a combination of an unmanned aerial vehicle and a landing module, designed to leverage Titan's Earth-like gravity and aerodynamic properties to maximize exploration capabilities. The equipment on the Dragonfly spacecraft is designed similarly to that on NASA's Mars Curiosity rover. Dragonfly, with its 4 pairs of rotor blades, will be powered by a nuclear source from a radioisotope thermoelectric generator. Rather than relying on sunlight, because Titan's atmosphere is too thick for light to easily penetrate, moon Titan has an atmospheric density 4.3 times greater and an atmospheric pressure 1.4 times higher than Earth. The vessel will be equipped with a suite of sophisticated scientific instruments designed to detect complex organic compounds and potential signs of life. Dragonfly could also conduct seismic surveys to explore the ocean deep beneath Titan's surface. It can fly dozens of kilometers in less than an hour. This makes its terrain observation and surveying capabilities far more flexible than those of a rover. With its 2-year mission, this spacecraft is capable of exploring and surveying hundreds of square kilometers of Titan's surface. As previous Cassini mission, which aimed to explore Saturn. With new breakthroughs discovered from the mission, the Cassini spacecraft was tasked with collecting the best possible data on Titan's features and structure, despite its thick methane atmosphere. Nevertheless, thanks to radar technology, the Cassini spacecraft was able to reveal the formation process of the surface hidden behind this moon's atmosphere. But the probe could still record images and accurately determine the composition of the dunes, mountains, and lakes. NASA's Juno probe has also made a similar observation to what Cassini once did. The Huygens probe, launched in 2005, was specifically designed to float on a liquid surface or land safely on solid terrain. Additionally, the probe is coated with a specialized material capable of withstanding the corrosive effects of methane and ethane chemicals. However, the Huygens probe was only able to conduct a survey within Titan's atmosphere. Because experts at the time were not entirely certain whether the Huygens probe could truly withstand the effects of the external environment. As mentioned, Dragonfly will be the first official probe to land on the surface of Titan, and is the first spacecraft to analyze the mysterious chemical composition on the surface of this captivating moon's Dragonfly mission to Saturn, and will attempt to gather evidence of life in the liquid methane lakes on Moon Titan. In the processing record, Cornell reported that these inspections were conducted concurrently. Other Dragonfly studies will be conducted to examine whether conditions on Titan are suitable for human life. According to NASA Director Jim Bridenstine, Dragonfly is the first drone-style lander. It can fly more than 160 kilometers through the dense atmosphere of Titan,